Good afternoon, everyone. My name is Yichen Liu. I'm a PhD student at Indiana University, and today we are going to talk about some security issues in Matter. Today, there are many IoT vendors like Google, Apple, SmartThings, and they really have their companion apps like Google Home, Apple Home, and currently there are many IoT development frameworks such as Tuya SDK, HomeKit, and so on. The current IoT ecosystem is fragmented, and to overcome the fragmentation and heterogeneity, the Connectivity Standard Alliance proposed the Matter project, which is a universal open-source application layer connectivity standard. Since late 2022, the major IoT vendors have deployed support for Matter in the IoT devices, companion apps, and the development frameworks. And to this trend, the users using Matter protocol is growing rapidly worldwide. And to better understand how Matter protocol works, first I'm going to briefly introduce the data structure of Matter protocol. A fabric in Matter refers to a virtual network, and which includes multiple Matter nodes. The Matter nodes can be Matter controllers or Matter devices. And in this picture, the Matter plug in the center belongs to the Google Home, and Google Home is a controller to the Matter plug. And the plug also belongs to the Apple Home, and Apple Home is another controller. So a Matter node can belong to multiple fabrics simultaneously. A node usually has its node ID and clusters. Clusters represents to a set of functionalities or attributes maintained inside the Matter device. And fabrics have their fabric ID, vendor ID, label, access control list, and so on. Based on the background, we have three key research questions. The first one is, how do real-world IoT vendors integrate Matter to existing IoT devices and applications? And the second one is, can vendors securely integrate Matter to the devices and applications? And what is the error space that we should be aware of? The third one is, how well does Matter as a standard define and support IoT vendors' secure integration? We define UMCCI. In the IoT mobile app, vendors usually develop their user-facing Matter control capabilities and interfaces. For further convenience, we define them as UMCCI. They can be GUIs or voice interfaces. And for users to view, use, or control the Matter devices through Matter controllers. Here are two examples of the UMCCI in Google Home and Apple Home. Users can view all the controllers, and they can add or remove the controllers. And to answer the research question 1, we analyze the Matter deployment model in the wild, and we divided them into 3 layers. From the bottom, there are Matter open source layer, vendors application layer, and the cloud layer. And we uncover the security responsibilities for each of them. First, for the Matter open source layer, there are device firmware and the Matter SDK, which refers to the chip SDK. And it contains a range of primitive capabilities to communicate with or control the Matter devices. And built on top of this, the vendor's Matter application layer, the vendors will develop their Matter controllers integrating the Matter SDK, and using the SDK APIs to control and manage their Matter devices. Matter controller here is a logical concept, which refers to some apps or IoT hubs, like some smart speakers. And to securely integrate Matter, here we propose 3 security requirements. The first one is users should be able to view the access control information. like the Matter controllers, the Matter nodes, and Matter access control list information. And second, access control information should be trustworthy. And third, users should be able to update access control information, like they can establish or revoke control for Matter devices. However, how to develop and design the UMCCI to securely integrate Matter depends on each individual vendors, so they can easily go wrong and contains some serious design flaws. We find that the apps of Apple Home, SmartThings, Google Home, and Tuya, they're all problematic. They either contain a partial list of the controllers, or they show unverified controller information. This can make unauthorized users, malicious IoT users, to hide their control from the IoT device owners. And we reported 6 types of UMCCI flaws. Each of them allows unauthorized controls over hidden Matter controller or convert control channel, and they even allow unauthorized control to downgrade or remove the IoT owner's privileges. We studied 11 vendors and find 8 of them are problematic. And we use proof of concept attacks to prove that the UMCCI flaws are real and practical. Next, I will use flaw type 1 to demonstrate the UMCCI flaws. In this picture, the Matter plug belongs to Chip Tool and SmartThings. The Chip Tool is a developer tool which is contained in the Matter open source project. And it serves as a controller here. The SmartThings serves as another controller. And in the Chip Tool, we can use commands to see there are 2 fabrics, the Chip Tool and SmartThings. And each of them have their individual vendor ID and label. And in the UMCCI of the SmartThings app, we can only view 1 fabric, the FFF1, which corresponds to the Chip Tool. Then, if we use the command update fabric label in the Chip Tool to change the label of Chip Tool to SmartThings, now in the UMCCI of SmartThings app, there are no fabrics. So for the attack scenarios, in shared home scenarios like Airbnb, if a host shares the device with a malicious guest, and the guest can use Chip Tool to stealthily control the device, and after the guest leaves, the host cannot remove a hidden controller in the SmartThings UMCCI, so the guest can still control the device. And for the time constraint, we are not going to discuss all of the vulnerabilities. And if you are interested, you can visit our website. And now, how to detect the UMCCI flaws? We designed an automatic tool called UMCCI Checker, which is based on the LLM-assisted UI analysis. The aim of UMCCI Checker is to check the IoT apps. So we do not rely on purchasing or configuring real IoT devices. And we developed a virtual Matter device to pair or cooperate with IoT apps. And the workflow of UMCCI Checker contains 5 components. There are virtual Matter device environment, automatic device pairing, efficient automatic UI exploration, flaw analysis and reporting, LLM-based Matter agent. Next, I'm going to use the flaw type 1 example, as an example to demonstrate how the UMCCI Checker works. First, we are going to initialize the virtual Matter device. This including extracting the parent code from it. And then we initialize the Chip Tool and use the parent code to pair with the device. And next, we are going to initialize the SmartThings mobile app. we install and launch the app and do the registration. Next, we are going to extract all the UI elements and send to the LM agent. With the help of LM agent, we are going to automatically do the device pairing operations in the SmartThings app. And we'll continue to do this until the app is successfully paired with the device. And next, the UMCCI Checker is going to explore all the UMCCI pages. And in this part, we are also going to extract all the UI elements. And we're going to find the semantics of the page, whether it's similar to connected services or Matter controllers. And we're using this to define, to identify the UMCCI pages. And after this, we have collected lots of UMCCI pages, and we are going to run multiple times of the testing. And when the chip tool changed the labels to arbitrary strings, and when it matched the vendor names, we are going to find that on the UMCCI page, this fabric is not displayed. And this indicates we find the flaw type 1. And finally, I'm going to summarize our work. We propose new understanding and new attack. This includes how vendors integrate Matter standard to IoT devices and applications. And we provide the error space of vendors' Matter integration. And we also discuss the root causes of security risks in vendors' integration of Matter. And we propose new detection and mitigation techniques. Finally, we discover UMCCI flaws from 8 popular vendors that integrated the Matter standard. And we perform proof-of-concept attacks with 11 real devices. And this has all been acknowledged by the vendors. Thank you so much for listening.
Thanks for your presentations. Questions? So you mentioned that you contacted these vendors. What was their reaction, and are they doing anything about it? Are they patching, or?
Yeah, actually, we have displayed all of this response in our website about how they respond to this. Because we have divided all the flaws into 2 types, like from the vendor side and the Matter design side. So their replies are quite different. Like for the vendors, they are going to repair this issue because these are related to their designs. And for the Matter, actually it takes time for protocol standard to mitigate such issues. But they are replied very actively.
Okay. Good to know. Thanks.
Yeah. Thank you
so
much.
All right, let's thank the speaker one more time.